The figure below represents an insulated cylindrical cord of copper wire wound round a paper tube. Full stop. The ends of the coil are connected to a sensitive galvanometer. Full stop. When a magnet was plunged into the coil, it was observed it was observed it was observed that the galvanometer needle gave a deflection. Which of the following correctly describes this experiment? Look at the diagram here. Now, option A, the effect illustrated is induced electromotive force. Option B, the strength of the current produced is inversely proportional to the speed with which the magnet is plunged into the coil. Option C, the direction of the current is always such as to enhance the change producing it. Option D, on removing the magnet from the coil, the galvanometer deflected in the same direction. JAM 1984/50. Which one is the answer? Huh? Okay. Reason. Reason why the answer is one. Number one reason, induced current. Here, you say when the magnet is plunged or moved relative to the coil. When now the magnetic flux through the coil changes. The magnetic flux through the coil changes. You say the flux, that is the change, the flux changes. The flux change. Give me duster. Put that duster. The flux drives momentary electricity. Sorry, momentary electric current. Or you say momentary electricity, but let's use momentary electric current. But then make it in a way you understand. Let me say the change in the flux induce EMF, which drives momentary electric current. This one is more understandable. Do you understand? So number two, detection. Another reason why the answer is A, detection. Here you see that the sensitive galvanometer detects induced current, which causes the needle to deflect. The sensitive galvanometer detects induced current, which causes the needle to deflect. Now the third reason is direction of the deflection. Direction of the, just say direction of deflection. Direction of deflection. Here, we say that the induced, the deflection of the needle, here you say that the deflection, the deflection of the needle causes, deflection of the needle depends on the, sorry, here you see that the deflection of the needle depends on the direction of the magnet. The deflection of the needle depends on the direction of the magnet. So here, for example, you can see that when the magnet is moved out of it, that is, the coil of the wire will be in opposite direction compared to the deflected needle. Do you understand? The space here will not contain what I'm about to say. For example, this, when a magnet is moved out of it, let me say, for example, when a magnet is moved out of it, comma, what I mean out of it, out of the coil of the wire, move out of the coil of a wire, comma, you move out of it, comma, let's just say move out of it, the coil of the wire, out of it, the coil of the wire, moves, when the magnet is moved out of it, out of the coil of the wire, say out of it, the coil of the wire moves in opposite direction compared to the deflection, or should I say compared to the deflected needle, or you say compared to the deflection of the needle. So these are the three reasons why the answer is A. Number one, number two, number three. Did you understand? So you can read the question again. Did you understand? See you in my next class. Thank you. Please do it to subscribe.